Alright, so good morning everybody. We are back with logic, and this time we're going to be taking a look at what are called the rules of replacement. We've looked at the first 8 rules earlier, so these are the additional 10 that you're going to be learning. With these, there's a new symbol that we have to consider, and this is the double colon. Basically what it means is that whatever is on one side of the double colon can be replaced with whatever is on the other side of the double colon. So there should be no change of value, there should be no change of truth value shifting from one to another. It will essentially mean the same thing. So in 7.3 we are introduced to these 5 rules of replacement. Each of these deal with the dot and the wedge. We have Demorgan's rule, DM, which basically says that if you have P and Q in parentheses negated, that is exactly the same as not P or not Q. And if you have P or Q in parentheses negated, that is exactly the same as not P and not Q. Now, why would you want to use something like this? Well, it could just simply help you to solve a particular problem. Suppose that you had a issue such as this, where you have your first equation is not P or Q, and you wanted to reach the conclusion of not P. Well, the way it's stated here, there's really no way you can do that using our 8 rules. But if you use Demorgan's rule, not P or Q is the same as not P and not Q. And then you can simply simplify the not P and not Q to not P in that fashion. So it just becomes another way of being able to work with the problem. The second rule that's introduced to you here is called commutativity. I consider this one to be kind of a redundant rule because we've already seen that with the dot, with the wedge, even with the triple bar, the order doesn't matter. It's only the conditional, the horseshoe, where the order actually matters. But this one is a rule that reminds you that P or Q is exactly the same as Q or P, P and Q exactly the same as Q and P. For my purposes, I don't particularly care most of the time if you use commutativity. You can simply waive that one if you want to. I think it's perfectly acceptable to do that. The third, associativity, abbreviated ASOC, basically says that if you have 3 letters joined by the wedges or the dots, I misdrew that, didn't I? Sorry about that. So if you have the 3 letters joined by the wedges or by the dots, it doesn't matter where the parentheses are. So P or and then Q or R in parentheses would be exactly the same as P or Q in parentheses or R. The same thing with the dot, P and Q and R, then P and Q, then R. And again, it's just simply a matter of helping you to solve a problem if you are stuck in a situation where it doesn't look feasible in some other way. So let's say we have, for example, on line 1, we have P or Q or R. And then on line 2, we have not Q or R. And we want to reach P as our conclusion. Well, again, the setup isn't right here, but if we use associativity on this first line, it becomes P or Q or R from 1 through associativity. And then P or Q or R, not Q or R, therefore P. Or if you preferred to use it, you could use the commutativity here too, make that Q or R or P. Again, I would not require this of anybody, but if you chose to put that in there, you could. But in any event, the point is that you're going to have a disjunctive syllogism now. It's not Q or R, so it has to be P. All right? So that could be either from 2 and 3, or from 2 and 4, depending upon whether you use commutativity or not through Demorgan's. Through modus ponens. No, disjunctive syllogism. Sorry, it's 7 o'clock in the morning. I'm trying to do this here. Disjunctive syllogism, but that's the way it works. So it's just another tool that you can use to help you in that respect. And then we have distribution. Distribution is doing exactly what it claims to do. It's distributing the initial letter throughout. So P and Q or R would be the same as P and Q or P and R. P or Q and R would be the same as P or Q and P or R. Okay. And again, it would be the same basic issue. You'd use it based upon your need within the groupings. And the last one is one you've already are familiar with, and that's the idea of double negation, that P is the same as not P. Two negatives cancel each other out, so the one is equal to the other. So those are the rules of replacement that we are dealing with in 7.3. So, like we've been doing, the easiest way to do this really seems to be to just kind of jump into some of the problems. And we'll take a look at a few of these. The first one, we come to 7.3 section 1 on page 417. The first one here we'll just look at. It says not E then H, not N or G, not A or D. And then line 4 is the conclusion we're trying to reach, and like the last one, they're telling you what maneuver they want you to use. So they want you to use Demorgan's. So with Demorgan's rule, we have to figure out which of these lines looks like it, basically. So we look under Demorgan's, and we want to see something that looks like one of these 4 forms. Well, line 2, you have not N or G. Not N or G would become not N and not G. From line 2 through Demorgan's. It can't be line 1 because that uses the horseshoe, and we don't use the horseshoe in any of these rules here. And the not A or N isn't going to work because it wouldn't have the parentheses around it. So only 2 matches the form for a Demorgan. So we just simply take from what's on one side and replace it with what's on the other. So you'd end up with not N and not G, line 2 from Demorgan's rule. Okay. Let's do one more of those. So number 2, we've got G, then N, then K. Line 2, we have R or D, then F. Line 3 is S, N, T, or U. And line 4 is what we have to figure out, and they want us to use distribution. Alright, so we're looking at distribution, so we're going to look right here. And so we're looking for one of these lines that matches one of these 4 basic forms. We know it's not line 1 because that's the horseshoe, and none of these use the horseshoe. Same thing with line 2, actually. There's a horseshoe there, so we know that one's out. So it has to be line 3 where we're looking at S and T or U. Well, that basically looks like this one, P or Q or R. So we want to make it look like this, P and Q or P and R. So basically S and T or S and U. Okay, so it's actually pretty easy in that respect. And this is primarily what I'm concerned with, is just getting you guys familiar with the basic ideas. So I'm going to let you try for homework the rest of those on page, well, it's on my book, page 417. So you can do numbers 3 through 15 under section 1 there, 3 through 15, and that'll be enough to get you familiar with the basic formats. I'm not going to worry about the section 2 on this particular set, and I'm not going to put a lot of emphasis on the working proof, simply because if you understand how to do one, you understand essentially how to do them all. It's just that once you add these rules of replacement in here, in addition to the rules of inference, it becomes a lot more complicated than it needs to be, really. And it's not as much fun. But nonetheless, I will do one with you here. So we'll just take the first one. It says not M then P, and not N or Q. Not N then Q. Line 2 says not M and N. Therefore, P or Q. Okay. So looking at this one, what I notice is that here there are two conditional statements joined by a dot. And the conclusion I want to reach are the two consequents joined by a wedge. Well, that looks like a good setup for a constructive dilemma. The problem is that for a constructive dilemma, I need the not M or not N, right? The two antecedents joined by the wedge. I don't have that. What we do have, though, at the second line is not M and N. And if I look at Demorgan's rule, not M and N would be exactly the same as not M or not N. So I can use Demorgan's rule on line 3, make that not M or not N. And now we can draw our conclusion of P or Q from lines 1 and 3 through a constructive dilemma. Okay? And so that's basically all there is to it. It's the same thing you've been working on, the same thing you've been doing for the last two sections, except that now, in addition to the rules of inference, you have the rules of replacement as well. As I said, I'm not going to make a huge deal out of these, but I will give you a few to play with here. So the homework for this section is at 7.3, section 1. You're doing 3 through 15. And then at section 3, I'm going to have you do, since I did the first one, just do 2 through 5. I'll just give you a few of them to play with. And of course, I'll be back a little bit later to give you the answers on those. All right, see you in a bit for 7.4.